Okay, hey guys, before we start, I do want you guys to either turn on your mics or your chat just for like a couple minutes. I want to get your feedback on what you thought of the first two AP videos. Personally, I thought the first one was like very almost too easy. Um, but I thought the second one was a little bit better. The second one was actually a topic we didn't touch on too much, so I like that one a little better. Um, but I wanted to get your guys' thoughts on those first two.
Oh, I feel like the same thing with Elvia. It was just they used a lot of examples. Like after a while got kind of repetitive.
Yeah. Yeah, I get that too. Especially in the first one, like the first one they used, both of them they used a lot of examples, but the first one, like the examples were like so easy and so much the same. Let me see if I can find. Yeah, and I don't know, like, we'll have to see because they said that they're trying to, I guess some teachers hadn't taught this stuff yet. So they're trying to teach this chapter and then I think they're trying to go back and do review. So I don't know if they're gonna do like AP style questions or what. I do want us to watch today's because today's is on slope fields, and I think some of us weren't as comfortable with slope fields. I know we did that really quickly. Um, but what I am okay with is I want you guys to watch it, but if you start to get to where, hey, they've done like 10 examples on slope fields, I don't need you to watch all 10 of them. Like if your notes have two of their examples, and then the third example, you're like, all right, I do understand this. We did this in class. Um, if you want to just throw it on like 2 times speed just to make sure you don't miss anything important, but kind of stop taking notes until you see something that you're like, well, wait, I need to rewatch that. That's okay with me. Um, because I watched both of them too, and I felt the same thing that you guys did. That hey, the first one might have been just too boring, but the second one was really good info, but it was just um, kind of a lot of repetitiveness. Um, so I'm okay with that. All right. Now today for homework, it is the weekend. I do want you guys to enjoy your weekend, but at the same time, we are gonna have two homeworks. So homework one is gonna be the AP video. And then homework two is the 2011 calculator free responses. So it's numbers one and two. Um, I heard a couple of you guys, Elvia, did accidentally do this as part of worksheet 105. So, like, worksheet 105 was supposed to be numbers 3 to 6. If you happen to already have done one and two, then you've already done that second part of the homework. But those will be the two parts of our homework. So today we're going to get into the related rates. And more recently, for related rates, they haven't had a full question devoted to it. They've done something where part of it uses related rates and part of it doesn't. Um, to me, it is kind of the scariest topic that we get in calc. Um, but at the same time, really, Usually it's pretty obvious that it's happening because you're going to have an equation that either has an x or an r or some other variable, and then they're going to ask for a rate, like with some unit of time. So anytime you see a rate with a unit of time, that means we're doing d dt, which is going to imply that we're going to have related rates. So most of these are very, very similar. The only thing I wanted to do before we started is just talk about there is a cone question. And when we get the cone question, usually we have an R, kind of a big R, and a big overall height. And these two are constants. You can plug them in. And then they want the rate at some time when the cone is partially full. And so with this, you're going to have a little r and a little h. So if a question told you that, the cone has a diameter of 10 and a height of 20, and then they give other information and they want you to, like, say, find the rate, the height is changing when r equals 2. Okay, well, what we can do here is we can actually just kind of plug in 10. Now 10 is diameter, right? So if diameter is 10, that means radius is 5. But this is for big R because this is the overall cone. So we can kind of draw our same picture. But make our big R 5. And then our big H was 20. And we kind of see that we have two triangles and they're similar triangles. So we can say that if we wanted 5 over 20 equals, right, this was big R. So then we need to match up big R with little r, equals on top little r over H. And now you can cross multiply and get 5H equals 20R. And so this here is now a formula we can use. Okay. You can use it to plug in. So if we were doing something with volume, right now, if we're looking for the rate of the height, then we want the height. So then we want to replace the R. So we're going to solve for R. So divide by 20, and we would get 1/4 H equals to R. So in our volume, we would plug in. Right, and now we just have one variable on the right side, and then we can solve with this. Okay. So that's kind of the one thing that is not so intuitive, that we're not used to as much. One more thing that does happen on certain problems is we get these kind of, maybe it's a ladder. And we get these a squared plus b squared equals c squared problems. And when we take the derivative of that, we get 2a dA dt plus 2b dB dt equals 2c dc dt. And the 2's are always going to cancel out. So if you remember, you could just jump straight to the shortcut, which is just writing these without the 2's. And specifically on the latter question, it's really, don't try to memorize this because it's not going to happen on every single question. But specifically on our latter question, right, this is a ladder, it's a constant, it can't change. So anything that we know is a constant and can't change, its derivative is going to equal 0. So this whole side would equal to 0 just for the latter question. Now that doesn't happen for every question, right? If we saw like that train question we had where one train was going up and one train was going to the right. Now C is changing. So you wouldn't have been able to do that, right? Like you wouldn't have been able to cross out that 0. So just remember, like, so on this question, right, we would have to plug in for everything. So that doesn't always happen. The other thing that can happen for us is they might give us an angle theta and they want to know about d theta dt. And they usually do this one when we have the constant. So if they do this one and you know that C is constant, then you want to use C, right? Like you could use sine, cosine, or tangent. But if you know that dc dt is going to equal 0, because it's constant, then it makes the most sense to use either sine or cosine, because that only gives us one variable. Right, sine's opposite over hypotenuse, cosine's adjacent over hypotenuse. The hypotenuse is constant. So those are just kind of some reminders before we start the problems. Okay, I know these are the scariest questions, but hopefully kind of doing these together gives us a feel for what they're going to ask us. And then I do have some more examples for us to work out next week. So this first question, by the way, I know I didn't post this file really in time. I posted about 5 minutes before we started. So if anyone wants to hop on a computer or anything and get the file, you can, or you can get it later and work out some of these problems on your own if you feel like you just need more practice. So first question is giving us an above ground swimming pool, and they gave us a shape, which is nice. Do be careful anytime on circular questions. Just really be careful between radius and diameter. This question was nice to us and gave us radius, but some questions do give diameter, and if you forget to divide by 2, you'll be losing some points. So the pool contains 1,000 cubic feet of water at time 0. So that's an important thing to be thinking about. During the time 0 to 12, water is pumped into the pool at a rate of P of T. So into is P of T. And then that's in the table, right? P of T is in the table. Then during the same interval, water is leaking at a rate of 25 e to the negative 0.05 t. And then they give us this note, the volume. So they give us the volume formula. Now, most of this question is actually not a related rate. Most of this question is, we're seeing this rate into, and we're seeing this leaking, which would be a rate out of. So most of this question is going to be a rate in minus rate out question. But they do have at the end kind of a related rate, so that's why we're looking at this one. So A and B, I'm going to jump through very, very quickly. So A is use a midpoint Riemann sum with 3 subintervals to approximate the total amount of water that was pumped just into the pool. So if it's only into, then we don't care about adding on the initial. We don't care about how much comes out. We only want the into part. And for midpoint Riemann sum, that means that we're going to be using the values in the middle, and they say with 3 subintervals. So we're going to just come up here and make sure we have 3. And then we're going to write out our midpoint Riemann sum. Guys, give me 1 second. I got to pause the video for 1 second. If you guys want to try to go ahead and work this out on your own, you can. Part A, I'll leave this up so you guys can see it, but I need to run really quickly to the other room. It's okay. All right, I got Emerson with me for a minute. So, anyways, we wanted the midpoint Riemann sum, so that was the integral from 0 to 12 of P of t. That's going to be our into. And so each one of these is 4. So if you want to factor out your 4 at some point, you can. But it's 4 times the middle is 46. Plus 4 times the middle is 57. Plus 4 times the middle is 62. Almost always on midpoint Riemann sums, your width is going to be the same. So because that width is the same, if you want to do a little bit less math by hand, since this one is by hand, you could go ahead and factor out the 4. Now, this and this answer will be in feet cubed. This is a perfect answer at feet cubed because it was cubic feet is feet cubed. It was cubic feet per hour, so we're going to chop off the per hour when we take that in. Now, you're going to have to, I'm going to have to pause one more time. I'm sorry, guys. So what I was saying is this is a perfectly fine way to leave your answer. You don't have to do the math out. But because in part C, it's actually going to ask us for the exact answer, I'm going to do the math here. So we just add up 46 plus 57 plus 62, right? And you should get 165. And we multiply that by 4. And you'll get an answer of 660 feet cubed. So there's part A. Part B then asks us to calculate the total amount of water that leaked out. So even though we see the word total, a lot of times total, we're thinking we do need to add the initial, but we just want the water that leaks out, okay? We just want the water that leaks out. So again, we're not going to add the initial because it's only the total leaking out, not the total amount in. So we just are caring about R of t, the amount coming out. So this question is the integral from 0 to 12 of R of t dt. And actually, this was a calculator question. So we could have typed this into a calculator. For some reason, I thought it wasn't at first. So the R of t was 25e to the negative 0.05t. I don't think you guys want me to go over how to type that into the calculator. I think you guys are okay doing that. If you need me to, just someone hop in the comments and say, yeah, we want to see it on the calculator. But otherwise, I'm going to skip that. So this would just become, we type it in the calculator and we would just get 225.594. And again, it's feet cubed. They gave 1 point here and 1 point here. Okay, Elvie, are you saying that like instead of the 46, they're saying like P of 2? Is that what you're saying? Okay, yeah, so you don't have to do that whatsoever. Elvie was saying sometimes in the answer keys, they might say 4 times P of 2 plus 4 times P of whatever. I don't generally do that. It is good to understand where it's coming from. Like the 46 is essentially P of 2. And then really the 4 is because it's the width. So really it's like B minus A. So that's, if we were to write like a very generic formula, that would be the formula. But they're going to give you full credit if you just skip that line and you just start by writing in the numbers. So if anyone really wants to write in those like, you know, P of 2 or F of whatever it is, you can. But writing it this way, you would get, for this question, you would have gotten 1 point here, and you would have gotten 1 point here, and it was worth 2 points, so you would have had a 2 out of 2 for part A. So if you see that in the answer key, they're just kind of showing where did these numbers come from, but it's not necessary for you to write it down. Okay, part C is going to ask us to use our answers from part A and part B to approximate the volume of water in the pool at time 12, and then round your answer to the nearest cubic foot. So in this question, now we are going to include the starting because we want the water in. So in this case, we are going to say that the amount of water at time 12 is equal to the amount of water at time 0 plus the integral from 0 to 12 of what came in, which they called P of t, minus the amount of water that left, that leaked, which we called R of t, dt. And so our initial was, they gave it to us, was 1,000. And then plus P of t was our answer from part A. So in part A, we had found that it was 660. And then minus R of t was our answer that we just calculated, which was 225.594. And we'll go ahead and we'll add up all three of these just using a calculator. And you would get 1434.406. And they said to the nearest cubic foot. So this would become 1434 feet cubed. And they only made this question out of 1 point because you had already done the work for these two numbers, like the 660 and the 225. So really at this point, I was just putting them together. 660 is an approximation, right? So yeah, Maria, so this would probably be better to use an approximation symbol here because if we read this, it says, use your answers from A and B to approximate the volume of water, right? Because our answer from A is an approximation. That's a good question. So also in our work here, thank you, Maria. This should have had an approximation symbol. From what I've been told by the AP graders is that probably about half the students forget that approximation symbol and they still give them points. They're not taking off a point if you don't have the approximation symbol. But it's good for you. Remember, they're going to be grading these questions quickly. And if there's ever an instance of them deciding, am I going to give this person the point or not? Usually it's pretty clear cut. Like usually either you have 660 or you don't. But in those cases where it's a little bit more subjective, if they're seeing like good math, like approximation symbols and stuff, they might lean towards giving you the point. So it's good to do that when you can. Okay, and then D, this is where we actually have our related rate. Find the rate at which the volume of the water in the pool is increasing at time 8. So we want to really see, we see this word increasing. We saw the rate. And what is increasing? They want the volume, right? So immediately when you see increasing in volume, you want to just write that's dV dt. So that's what we're looking for. And it says, how fast is the water level rising? So again, that's another increasing. Water level is a little tough, but kind of think, what would we call the 12? We would probably call the 12 like a big R. What would we call the 4? We'd probably call the 4 like a big H. So that would be the height, but it's also the water level, right? The water level matches up with H more than it does with R. So they want us to find dH dt at time 8. And it says indicate units for both. So this one's a little kind of funky, honestly, but we're going to kind of look at it. So for D, right, our volume was equal to, the volume is how much water is in there. So our volume essentially is just equal to P of T minus, sorry, our volume is equal to, that's my fault, 1,000, right? Okay. So our V of some time formula is equal to 1,000 plus the integral from 0 to some time t of P of T dt minus R of T dt. All right, that's kind of our generic formula. Now, V prime, right, like dV dt, or V prime, would be the derivative of this. So the derivative of this, right, that goes to 0. This we just plug in, so we just get P of T minus this we just plug in and we just get R of T. And this kind of makes sense because this is like our total rate is equal to the rate in minus the rate out. So that kind of does make sense that that's our formula. But this is a little tough because it's a lot of students were like, well, why don't we do V equals pi r squared h yet? And the answer to that, if you tried to do V equals pi r squared h at the beginning, would be that, well, we are going to get there, but we don't know anything about what dr dt is, and we don't know anything about what dH dt is. And essentially, you need one of those if you're going to try to solve for dV dt, right? This is too many variables. So we need some way of connecting them if we're going to do that. And since we don't have any way of connecting them, we're actually going to have to start off with the total rate, which you didn't have to write. You didn't have to write this first line if you just kind of remembered, hey, you know what? Total rate is rate in minus rate out. And dV dt is the total rate because essentially that's what volume is, right? Volume is the amount of water. So dV dt is like the change in the water. So it's a little bit strange, but that's kind of how that works. So basically they wanted to find the dV dt at time 8, right? So you can write this one of two ways. You can either write that what we're doing is we're finding dV dt at time equals 8, or you can write that as v prime at 8. Okay, either one of those two is fine. And so you're going to equal this to p of 8 minus r of 8. So either one of those is fine. P of 8 we're going to get from the table. So in the table, P of 8 was 60. And then R of 8, you're going to have to plug into your calculator. But essentially, it's that 25e to the negative 0.05 times 8. So you'll go ahead and type that into your calculator, and you'll end up with 43.241. And it asked us for units, right? Well, it's the same units that P of 8 had, the same units that R of 8 had. Or you could even just think of it as like dV dt, right? Volume units are feet cubed, and the time here was per hour. So this is feet cubed per hour. Okay, now that was only part 1, right? Part 2 then asked us to find how is the height changing? So this is where we are going to go in and say volume equals pi r squared h. This is our formula that has our height in it. And we can always plug in constants. So I told you guys about, kind of thinking about in the cone question where we did in the cone question, we did the whole big R, big H, and then we had little r and little h. Well, that's because they're both changing. But the nice thing about a cylinder, anytime you get a cylinder, is that actually big R is constant. And because constants, that means that like dr dt would equal 0. So because we know that about constants, we can actually always just plug them in immediately. So what that means for us is that we can just plug in 12 squared h and get volume equals 144 pi h. So we just plug that in, and now we have a formula with just 2 variables. So now we can solve for one of them if we know the other. So what we're going to do is we're going to kind of take the derivative of that. So the derivative of the left side would become dV dt. And the derivative of the right side, 144 pi is all a constant. So we're just doing the derivative of the h part, which is 1 dH dt, right? We need to multiply by the dH dt because we're taking the derivative with respect to time, and those are different variables. So we have to do that implicit. So now this gives us 43.241 equals 144 pi. dH dt, we just divide by 144 pi, and we'll get 0.095 equals dH dt, but it asked us to indicate units. So for our units, right, the units of height are in feet, per the units of time are in hour, right? We just look at those units and those units. That one was really kind of just a strange question, but hopefully we kind of understand the setup of that. So we're going to go to the second one. The second one says a cylindrical can of radius 10 millimeters. So this one didn't give us a picture. It's a good idea to just kind of draw out a picture. So a can is a cylinder. They also said the word cylinder. And they're giving us radius equals 10. Is used to measure rainfall in a storm. The can is initially empty. So kind of our amount at time 0 is 0. And rain enters the can during the 60-day period. The height of the water can be modeled by the function S, where S is in millimeters, and T is in days. Now, this is the height of the can, not the volume. Okay. The rate at which the height is rising is given by S prime of T. Okay? So that's the rate. According to the model, what is the height of the water in the can at the end of the 60-day period? So A is just the whole rate thing that we've been doing. S of 60 equals S of 0 plus the integral from 0 to 60 of S prime of T dt. You would just type this into your calculator, right? S of 0 is 0. They said it's initially empty. So you would just type into your calculator the integral from 0 to 60 of 2 sine of 0.03 t plus 1.5 dt. And you would get S of 60 equals 171.813 millimeters. Does anyone need me to show like a refresher on how to type in integrals to the calculator? Or we're okay with that? So B then asks, according to the model, what is the average rate of change in the height of water in the can over the same 60-day period? So the average rate of change of the height in the can over the 60-day period and show the computations. Okay, we can do this one of two ways. We'll get the same answer either way. So we see the word average, and what the average rate of change of the height. Okay, well, S is the height. And S prime was the rate of the height. So the average rate of change formula is that we're going from height to rate, and that's S of 60 minus S of 0 over 60 minus 0. Well, we can do this because we just found S of 60, so we can plug that in. However, some of you guys might also think, hey, I see rate of the height and I want the average rate of the height. Those are the same thing. So that's the whole 1 over 60 minus 0 integral from 0 to 60 of, now this would be S prime of t dt, because we're thinking of itself, right? Itself is the rate. Either way you do this, you'll get the right answer, right? Because S of 0 was 0. I'm going to do it the first way in green. So S of 60 was so I might just write like average rate of the height equals, right? And then this was 171.813 minus 0 over 60. And we type that in and we get 2.863, and they wanted units. It's millimeters per day, because those are the units they're giving us, right? And think, what were the units of like the 171 were in millimeters? What were the units of the 60 minus 0? Those were in days. So that's how we're getting those units. Either way, the both averages will work. We just got to make sure we pick one and stick with it. Okay. C, assuming no evaporation occurs, they're basically saying that there's rate out is 0. What is the volume of the water in the can changing at time t? Now, this one is a little bit of a tricky related rate, and it's sort of not even a related rate, but I have it on this worksheet because it ties into it. So we want to know, how is the volume changing at time t? Well, the volume of a cylinder is pi r squared h. Right? And in this question, they actually didn't give that formula to us. They were kind of expecting that you knew it, but it's something where on more recent exams they have been given the formulas. So they told us back here that the radius was 10 millimeters, right? And we drew that in. And that's a constant because it's a cylinder. So what we can do is we can plug in that 10, and 10 squared is 100. So we get 100 pi h. Now, what they're asking us for is they want, how is the volume changing? So they want the dV dt part. We can't do, in the last question, we were able to just say, oh, the volume was just the rate. We can't do that because S prime is not the rate of the volume, it's the rate of the height. So what our S prime is really equal to in this case is dH dt. Right? So that's just kind of thinking about that. So a lot of times in these questions, I'll kind of have, in my related rates question, if I have enough space, I'll kind of split it up into 3, put my givens over here, put my formula over here, and take the rate over here. So our formula was volume equals 100 pi h. We got that because we knew that R was 10. And then over here, our derivative, it would become dV dt equals, right? When we take the derivative of this, we're going to treat 100 pi as a constant. So it becomes 100 pi times dH dt. Okay. And then I will look this up because there is a way to do implicit derivatives on your calculator where it'll actually give the like dHdt part, or I think it'll call it H prime, but I need to review how to do it before I teach it to you guys. I just kind of thought about that. Someone found it, I think 2 years ago. Anyways, so we were looking for dV dt. What we need to kind of realize is that dH dt was equal to S prime. So what that means is that dV dt at time 7, and you don't necessarily need to write that, or you could have also written V prime of 7 is fine, is equal to 100 pi times S prime of 7. Right, if you want to have first written out, this is 100 pi times S prime of t, you could have. Right, so now we're going to plug in 7, and when we plug in 7 and then multiply by 100 pi, we'll end up with 602.218. And they want units. Well, for units, volume is in millimeters cubed, right? Area is always squared and volume is always cubed. and time here was in days. So this is millimeters cubed per day. So this was a related rate. It was just a very different related rate. And lastly, it says, during our same 60-day period, the monsoon mountain accumulates in a can identical to the one in Stormville. And the height of that water is modeled by M, which is this weird function 1 over 400 times the quantity of 3t cubed minus 30t squared plus 330t. And for 0 is less than time is less than 60, let d of t, I'm assuming they're thinking difference for d, like the difference is m prime minus s prime. And they're telling us actually to use the intermediate value theorem to justify that there's a time where the two cans are changing at the same rate. So on more recent exams, they wouldn't have been that nice. They wouldn't have told you to use that. They would just say, basically, to justify that there exists a time where the heights are the same. And when we see kind of that key word that there must exist, we're using that key phrase to think, hey, we're thinking IVT or MVT. And then because we're thinking that the heights are changing, that's what they want us to figure out, that they're changing at the same, that then we're thinking IVT because we have the rates already. But basically what we want to think is we want to use the 0 and the 60. So we want to think, okay, what is d of 0 and what is d of 60? Hopefully one of these is negative and one of these is positive. So d of 0 is just going to be plugging in m of 0 minus s of 0 into our calculator. Or really m prime of 0 and s prime of 0, right? Because that's what this was, m prime of 0 and s prime of 0. Now, the one thing that a couple students got confused on this and got this question wrong on this exam was because this is m prime of 0 minus s prime of 0. But they gave us an equation for m, and up here they gave us an equation for s prime. So on your calculator on this one, again, I'm not going to jump on and do it, but what you had to be careful for was that this guy, we had to do the derivative of m, right? Of that 1 over 400 deal, right? I'm not going to write it all out. First, to get m prime, right? That we needed to do first. So you guys can try this on your own if you want to. But then s prime was already given to us. We already had it. So we didn't need to do this. For s prime, we just plugged in to s prime because we already have it. So when we do this, we get negative 0.675. So we're going to write in that that's less than 0. That's kind of key. We need to make sure we're writing that. Then for d of 60, we're going to do the same thing. And we're going to get 69.3773. And we're going to write in that that's greater than 0. Again, that's kind of a key thing. We have to show that. So now we can say, we probably should have mentioned that it was continuous. So kind of because d of t is continuous, IVT applies. And then we'd say by IVT, there must be a time the heights are changing at the same time, right? Conceptually, that's because the heights were changing at m prime of t minus s prime of t. And if that's equal to 0, we can add the s prime over and they would be changing at the same time. So anytime you have two things for IVT, if you subtract them and they equal 0, that's going to be changing at the same time. Or they would just be equal if it's not a rate. Because d of 0 was less than 0 and d of 60 was greater than 0, right? We showed up here that we had done that. So there's that one. Last one is our dreaded cone question, and this one is truly a related rate. I wanted to save this one for the end because this is the one that really is our full related rate. But we are going to have to go through it fast because we're running out of time. So A says find the volume of the container when H equals 5. Well, let's go back and read through this really quickly. A container has the shape of an open right circular cone. That's really just a cone, as shown in the figure. Now, they give us diameter. I'm going to go ahead and just get rid of diameter and draw in 5 centimeters for our radius. And I'm going to call it big R, and I'm going to call this guy big H. And then it says water in the cone is evaporating so that its depth H is changing. So when we see that, we know it's changing at a rate of -3. When we see changing, we're thinking it's a rate. So we know that dH dt is equal to -3/10. Right? That's what they gave us. So A is usually pretty easy on these. It doesn't really require any related rate type work. It's just plugging in. A was find the volume when H is 5. So our formula is 1/3 pi R squared H. The issue is they only gave us H. They didn't give us R. So what we need to make sure we're going to do is that we set up that big R, which is 5, over big H, which is 10, equals little r over little h. And we're going to go ahead and cross multiply. And so we get 5h equals 10r. Now, we could plug in 5 here and figure out what r is, and that works. But I like to solve because we can't actually get rid of r. It's not a constant. So I like to just solve. We're given h. So I'm going to go ahead and solve for r because I want to eliminate r. So that means that divide by 10 to both sides, we'd get 1/2 h is equal to r. And that means here we can plug in 1/3 pi times 1/2 h squared times h. Okay. And again, the reason I like to do that is just because we were given stuff about h, right? We know dH dt. We know that h is 5. Now, could I have plugged in and got 5/2 equals to r and just plugged that into r? Absolutely. Okay. But I'm going to have to do this step anyways, so I'm going to do it now. So this gives us volume equals 1/3 pi. We're going to square both of these. So that becomes times 1/4 h squared times another h. Simplifying this gives us 1/12 pi h cubed. And now we're going to plug in 5. And if you want to just leave your answer like this was a non-calculator because you forgot what 5 cubed was, great. If you want to plug it in and get 125 over 12 pi, great. But one thing don't forget is they say indicate units of measure. Make sure we don't forget that. So it's just a regular volume, and volume is in centimeters cubed or centimeters cubed, right? Because that's just kind of how volume works. It's always the units cubed. Area is always the units squared. Height, radius, those are always just the units. Okay. B then asks us to go ahead and find the rate of change of the volume. So they want the rate of change of the volume. So they want dV dt when h is 5. So on these, again, a lot of times what I'll do if I'm looking for that, I'll kind of look at what are my givens. So in this case, my given was H was 5. Another given was dH dt was negative 3 over 10 centimeters per hour. And I doubt we're going to need it, but technically now we have a given that the volume is 125 over 12 pi centimeters cubed. Now, this one is changing and this one is changing. So these are only at this specific time. So we got to be careful. We cannot plug those in until after we've taken the derivative. So our volume is pi r squared h, or better is 1/12 pi h cubed, and we're going to use this version, right? We already did this work by plugging in this kind of ratio, right? So this is the volume we're going to mostly be using because it got rid of the r and we don't know about dr dt, right? If we took the derivative of the top one, we would have had to do a product rule because we have two different variables, and we'd end up with a dr dt, which we don't even know about. So that's why it's really, really important on these cone questions to remember about doing that similar triangles. So we're going to do derivative of the left side, derivative of the right side, and we get dv dt is equal to, okay, we're going to bring the 3 in front, so 3/12, which is 1/4, pi h squared. But don't forget, the thing that most students forget is, okay, this is dt, so it's times dh dt. We just kind of need to remember, anytime we're doing these rate questions, we always do times d what dt, dr dt, dh dt, whatever it is. So now we have a formula. We were looking for dv dt, but we do know everything else. So this is 1/4 pi times 5 squared times negative 3/10. And again, this is fine. Leave your answer like this. You get full credit, but they do want the units. So make sure we're getting our units in there, which is volume units are centimeters cubed. And in this case, it was time units gave us were hours. So that's our formula. Okay. If you want to multiply it out, great. You get 25. The 10 and the 25 might cancel out. We should end up getting negative 15 over 8 pi centimeters cubed per hour, but that's not really a better answer at all than the other one. So we're good there. Okay. And part C very quickly says, show that the rate of change of volume in the water due to evaporation is directly proportional to the exposed surface area of the water. They did talk about in that first AP video about that being directly proportional type deal. So this is kind of, it's actually way easier than it looks, but you needed to have known what surface area is. So we were given the formula, or we had calculated the formula, dv dt equals 1/4 pi h squared dh dt. That's what we did up here, right? That was this formula here, because they wanted us to show, like what they asked was show that the rate of volume was proportional to, so K means like our constant proportionality to the surface area, right? That's what they wanted us. Well, what the formula for surface area is, right, surface area of a circle is pi r squared. Okay, well, what we can do is we can kind of come back up here to where we have h and r, right? Now, in this case, it's not at the 5. So we need to be here where we have h and r, right? And this is what we plugged in. But if we now solve back for h, we would get h is equal to 2r, right? Like times 2 times 2. So this was our formula where we could go back and forth between h and r. This is the kind of hard part of this question, is you need to realize, okay, surface area is pi r squared. So what they're looking for is they want us to show that there's some k and times pi r squared, because that's going to be our surface area. Well, we don't have r, we have h, but we know now that we can plug in for h as 2r. Okay. Now, dh dt was a constant. So if it's a constant, that means we can plug it in. So we can plug in -3/10. And so now we're going to get 1/4 pi times 4r squared times -3/10. The 4's can cancel out. And we end up with -3/10 pi r squared. So this is now kind of showing, yes, because this is surface area. So you can write, therefore, dv dt is proportional to the surface area. And then our constant would be whatever that number in front is. So our constant is -3/10. And that's it. Now, I think absolutely this part C was a little bit weird. It was only worth 2 points. So if you were able to get A and B, you got a 7 out of 9, which is great. We will look at some more of these in the future. I know they're weird, but it just kind of is what it is. So today for homework, like I said, we're going to have 2 things. Number 1 is going to be either at 11 a.m. or later, watching it later with sped up, able to pause. You're going to watch the AP video, and it's on, like I said, slope fields. And number 2 is I'm going to post worksheet 110, which is numbers 1 and 2, the calculator questions of the 2011 exam. Okay, I did talk to Ms. Velasquez about getting you guys charging cables. We're working on it. I don't know when they will arrive. If you guys would rather just spend a few bucks and get one sooner, I know right now Best Buy's doing store pickup. It's super, super easy. I actually had to do it for something for my laptop, and essentially you just order it for pickup. You go there, there's someone waiting outside, and they just you show them the order on their phone. You don't even have to get out of your car, and they just bring it to you. It's pretty cool. So if you want to order one of those cables on your own, you can. If not, hopefully we'll be able to get them at some point, but it might be a week or 2. Okay.
Happy birthday, Ewer.
What?
Happy birthday.
Oh, thank you. Yeah, it is my birthday. So thank you. I'm the big 3-0.
Happy birthday, Ewer.
Thanks, guys. So that's how much I love you guys, that I'm here doing this on my birthday. All right. So that's that. Thank you guys for the birthday wishes, and I will talk to you guys on Monday.